Greetings and welcome to AC Circuits. I am assuming that you have had DC circuits before now, and that you have completed it successfully. If not, you need to make sure you complete that first. We will be just a reminder. We'll have our first lab Monday, August 24th at 11 o'clock. Make sure you have your lab kit and everything from there. Meet in the lab room. We'll figure out whether we need to move and split up or not. And at that time, we will try and follow the syllabus as closely as possible in terms of our lab work. So please pay attention to that. Make sure you follow the directions getting into the building and while you're in the building, and masks should be worn at all times. All right, let's get on with this. Alternating voltage and current. We have already talked about DC. You may have an idea of what alternating current really is. In this case, we have more stuff in this presentation than we're actually going to talk about today. I'm going to use this slide set for the first 2 or 3 lessons, and I'll jump to those as we need them. Our first part of this is what is alternating current. Alternating voltage and alternating current. The resistance doesn't alternate, but the others too do. Allows them the magnitude and direction of the voltage and the current to alternate positive and negative. One cycle is the period of between two of the same value, such as when it starts at 0 going up. So next time it crosses going up, at that point it'll be the second one. And then when the frequency is measured in zeros, and hertz rather. We get that alternating by moving, let me get my highlighter, by moving a wire in a magnetic field. Or we can also have a wire and move the magnetic field around. Either way. We get one cycle as it completes. It turns. When this side gets back to this side again, that'll be one cycle. So one complete revolution is a cycle, and a half revolution is called an alternation. And that's going to be important in a minute. So if we look at the waveform, here's what it looks like. Quarter turn is at our maximum. We're at 90 degrees, or at pi over 2 radians. When we've flipped over, there's 90 degrees. This will be 180 degrees when it's flipped to here. It's a half a turn. We're back at 0 again, or pi radians. 180 degrees or pi radians. And then when we come on around here, we're fully negative now. 270 degrees, or 3 pi over 2 radians. And then all the way back to the beginning again. 2 pi radians or 360 degrees. Now, if we do this in 1 second, that's 1 hertz. If we do that and do 2 of these, that's 2 hertz. Angular measure, boom, boom, boom. A radian, and this is where it gets a little tricky. A radian is considered to be 57.3 degrees. It's the angular part of the circle. 2 pi, the radius is the circumference of the circle, so one cycle is 2 pi radians. Now, you don't have to know this, but it would help at some point in the future knowing this. But it's actually easier to worry about it in this fashion. Work it out. We call this a sinusoidal wave because it looks like a sine wave. And how we get that to show up on the scope is we'll worry about in the first or second lab. Yeah, I don't have to worry about that so much. Things you do know about these. Here's how it looks in a circuit. Current's flowing that way and then that way, and vice versa. Now, here we have three ways of discussing current and voltage and how it applies to the sinusoidal wave. Here's where the first test and the first stuff's going to be on this. That's peak value. That's the maximum value from here to here. So it's measured here. This is peak to peak. It's usually double the peak value, but it depends. Average value is the average of everything in 1/2 cycle. So all average of this here. And root mean square or effective. Takes that one and applies it over the whole thing. Now, we've already assigned values that the average value is 0.63 of peak and RMS is 0.707 of the peak. Now, you can learn these, but I wouldn't worry about it because you can get it back. Peak is generally half. Let me write this on here. Peak it's hard to write with a mouse. 1/2 peak to peak. Usually. Okay. Where'd it go? Anyway, I thought I had a stylus here. I don't. So if I have peak to peak, I can get peak, get about half of that. If you look at this, that's 2 times that. And that, in turn, is 2 times that. So all that can be derived back from there. Here's how it looks on a waveform. You know, it's basically like this. Here's my peak value, peak to peak. These are important because what happens when you use a digital meter, multimeter, to read this waveform, it's going to read the average. It's going to average them out. To get the RMS, you have to use a scope, or you have to multiply that out and figure it from average, from peak. Yeah, so we have to understand those in order to get the right answers. Here, they said the fault is in VRMS. We will give you whether it is in voltage RMS or voltage peak to peak, whatever. We'll give you that. It's the effective value. The heating of these is identical as if it were a DC on this part. That's why we tend to use RMS. Frequency is the number of cycles per second. A cycle is measured in 2 successive points have the same value, and 1 cycle per second is frequency. So here, I've taken 1 second, I have 2 cycles, so it's 2 hertz. If I had, and I want to show off my rather poor skills. There. there, that my frequency would be at 1, 2, 3, 4. Here, frequency would be 4 hertz. Okay. Audio frequencies are anywhere from 16 to 16,000 hertz. That's really low. I mean, my hearing is not that good anymore. Radio frequencies are up to 300 gigahertz or 300,000 megahertz. The higher the frequency, the higher the pitch. And amplitude has no relation to frequency. Amplitude is the loudness of the sound. Get ultrasonics, boom. Here's the key takeaway from this. T is 1 over F, and F is the reciprocal, 1 over T. Time period. There we go. Wavelength, we'll end with wavelength, and we'll get into the phase angles later. Okay? Wavelength is the distance the wave travels in a cycle. So it's velocity of the wave divided by the frequency. If it's light or sound, blah, blah, blah. If you ever go for your ham radio operators, this is the kind of stuff that you have to worry about and learn. So here, right, phase angle, we'll get into those because when we start worrying about this, we have to worry about phase angles. Okay. So we'll stop it from there for now. I'll pick up with phase angles and go into the next section for circuits with resistors going forward. Thank you. Have a good day. And I'll see you on Monday, August 24th at 11 a.m. Bye now.